Given that I've covered vaccines for so many diseases for so long, I am incredibly reserved about the pace of progress. In February, when I learned what the disease really looked like in a large group of people, and we got a clear picture that most people recovered, that gave me a sense that we could do this. But getting from there to a safe and effective vaccine, that's a big leap. There are 8 different platforms people use to make these vaccines. The vast majority focus on the spike protein. The spike protein is on the surface of the coronavirus. It attaches to a receptor on our cells. If you can block that with an antibody, in theory, you can prevent infections. The story I just told you, though, is a story. Antibodies aren't the whole game. A lot of viruses get past antibodies and infect our cells and get inside, and vaccines still work. We have a whole arm of the immune system called T-cell immunity that can target and eliminate infected cells. Antibodies are made by B cells. T-cells do the mop-up job when antibodies fail. T-cells also are the conductors of the orchestra and tell B cells and these killer T-cells when to go up, when to go down. So you need these 3 different things working in concert. The B cells making antibodies, the T cells that kill infected cells, and the T cells that direct the orchestra. Vaccines aim to do all of that. The simplest idea is you take the gene, which is what mRNA is, of spike, and you wrap that up in some fat. It hopes to create antibodies against spike, but it also hopes to create T-cell immunity. You can take the gene and you can put it inside of a Trojan horse, inside of a different harmless virus. Or you can make the whole virus and then you can chemically inactivate the whole virus. Take the whole virus or take the spike protein made in this big container, add some adjuvant to it that makes the immune system pay attention, and you can inject that. All of these different vaccines are working to some degree. There's also never been this much concentrated effort to understand why vaccines work. If we learn why this vaccine works precisely, I mean down to the level of antibody you need against spike or the N protein or whatever it might be, you can then take that information and instead of running an efficacy trial in 40,000 people with a placebo arm, you could possibly find better products simply by testing an experimental vaccine in a person, seeing what immune responses occur, and then pitting that against what we know actually works. And that's where we're heading down the road, to that bridging study that allows us to more easily evaluate what might be better vaccines for the future. I think supply and access and equity are now moving to the front burner. We're going to struggle to also do this equitably in a way that the rich people in the world aren't hoarding and benefiting from all the vaccine. I've covered HIV/AIDS for 30 years, and I watched lots and lots of people die from AIDS after good antiretroviral drug combinations proved their worth in 1996. I witnessed horrible things occurring against a backdrop of a phenomenal medical success. If this vaccine only helps rich people, we failed. But there is a mechanism, the COVAX facility, which is unique and revolutionary in its structure to try to address this equity and access issue. They're going to get out hundreds of millions of doses to resource-limited countries. I'm optimistic about our capability to do better, and I'm optimistic that we will have more momentum, but I'm pessimistic about how long the memory will last of how very bad this has been and how we really don't want to be here again.